Okay, this lesson is on transformations of functions, and we're basically going to focus on two particular functions. So if you would take out your calculators and have those ready, first thing we're going to do is go to y equals. Okay, go to y equals, and we're going to type in x squared. The shortcut key for x is up here next to the alpha key, and then the square key is over here above the word log. So that's x squared. And if you do zoom 6 so that you're looking at it on a standard window, it looks like a U-shaped graph. So what we're going to do is we're going to simply sketch in the U-shaped graph coming down and going back up like that. And so the first thing I want you to do is I want you to notice that this graph has a common turning point that's right here at the origin, or at 0, 0. We call that turning point the vertex, okay? And it will always turn at the x and y intersection right there at the middle. Okay, let's put the second one in our graph, and just to make sure that we all know where that's at, y equals, and I have an older version of the calculator, so what you'll do with your newer calculators is still the same button, second, and it's right above the x squared, and I'm going to take the square root of x. Yours will draw a bar across it, and I'm putting mine in parentheses, so I'm still saying take the square root of x, and we're just going to tap graph. And we see that it actually looks different than x squared. It actually starts at the very center. It starts here, and it kind of curves and goes up like that. All right. And this one has nothing on the left, so it actually starts, has a start point at 0, 0. Okay, you can call that the vertex if you want to, but it's technically the start point. And what this is this is actually half of a sideways parabola. Okay. It's actually what it would look like if you took the U graph that we have right here, and if you rotated it and kind of moved it sideways. That's kind of what it looks like, just trying to show you something of reference. So if you move that sideways, you're only seeing the top half. I'm really messing this up. Just trying to drag the graph. And so, of course, just to go back to fix this, of course, this one is right side up because this is the regular x squared graph. Try to do something quick and it doesn't turn out that way. But this is half of a sideways parabola. I guess I didn't say this U-shaped graph that represents x squared is called a parabola. And the emphasis is on the middle syllable, rab. So instead of being parabola, it's actually parabola. Okay. And so the other one is half of a sideways parabola. Now, it's just very important that you kind of commit these two graphs to memory. One is U-shaped, and one is half of a sideways U, just the top half. Okay, turns and goes up and to the right. Both of them have these points 0, 0 in common. So when they have those points in common, that's the one point I want you to do. So when it says memorize these two graphs, that's basically what I want you to do. Memorize these two, and from here on, we're going to compare these to others you see. Now today, I do want you to compare, use your calculator by all means, but try to see and understand the changes in the graphs and predict them without the calculator, because the quiz that you're going to take after we practice is going to be without a calculator. All right, but we will do plenty of practice before the quiz. All right, so what I want you to do next is I want you to put in number 1 in your calculator. Number 1, I'm going to type in x squared plus 2. And then I'm going to look at the graph and see if anything changed. Remember, we said we're going to compare the changes we see here to the one on the previous page. So if we go back and we look at this one, now let's go back and let's look at what happens when we say plus 2 on it. So we're trying to understand. It kind of looks to me like it went up, not 1 unit, but 2 units. And so if I were to draw the graph of x squared plus 2, it does look like it goes up 2. There's the start point and then the u. So it's almost like the graph started down here. Whoops. And it just went, it moved up 2 units, because that's exactly what happened. So this graph went up 2 units. All right. Let's look at number 2. And again, I do have an old version of the calculator. For you, it's going to look different, so we're going to go to y equals, and I'm going to make sure that I type in the square root bar with x, And then I want to subtract through 3 after the square root bar, okay? So in my case, it turns out to be square root of x. And I'm going to close parentheses to say, hey, that's the only thing I'm taking square root. In your case, you're going to actually do an arrow. So this arrow key right here stops your bar, and then you would do subtract 3. Subtract 3. Now, when we took a picture of the graph, what happened with this particular graph? What changes took place? And I hope that you can see that it looks like it went down 1, down 2, down 3. It still has the same shape. If instead of starting in the center, starting at 0, 0, this one looks like it went down 3 units. All right, so it's asking these questions just to see if you're able to detect which one went down 3 units. Number 2, which one shifted up 2 units? Number 1. Now, I want you to pay special attention because it's talking about when a value is added or subtracted to the function. Okay, what that means is, notice that I have plus 2 added or subtracted at the end. Okay, up here we have minus 3. We're subtracting 3 at the end. The graph seems to shift or move, and this is where you have to choose. Did it go up and down, or did it go left and right? And I think you can see that it went up and down. Okay, so up and down would be what you would circle. And this is very important because now you're actually learning how when we put numbers in the equations, it's moving the graph around the different places. And the number of units it moves is exactly the same as the number or opposite of the number. So let's read that again. And the number of units it moves is exactly the same as the number. Okay, so let's look right here. This was plus 2. And this actually did go up 1, up 2. And that number technically is positive 2 on the y-axis. So it did look like it had positive 2, and it did look like it went up to positive 2 or went up 2 in the positive direction. This one here says subtract 3, and it does look like this is actually landing on negative 3. So by my way of seeing it, it is exactly the same as the number. Not any different. It's exactly the same. Now what I'd like you to do is you're going to go from 1, 2, and then I think we have 3, 4, 5, 6, 7, 8. This is something that you can do, something we did as a class exercise. You're going to pause and you're going to sketch each one of these and answer your observation questions. Okay? So if we go back to number 3, type it in exactly the way you see it. Notice that this time we have parentheses that includes the x plus 2. Notice how this time the bar continues and the minus 3 is under the bar. So I want to pause. Okay, I'm going to pause. I want you to take a few minutes and I want you to do 3, 4, 5, 6, 7, and 8. See if you can answer the observation questions, and then I will join you in just a few minutes so we can see if you got the same answers. Pause the video. All right, did you successfully get number 3 and 4 drawn? Hopefully you used your calculator. Hopefully you got the images that I see. The first one looks like it went backwards, left 2. And number 4 looks like it went right 3. So now let's see if we can answer our questions. When a value is added or subtracted inside close to x, let me phrase that again. Inside close to x, inside close to x. Notice that what I'm trying to show you is this is inside the bar. All right, notice the 3 is inside underneath the bar. Notice that right here, this is inside the parentheses. All right, it's inside close to x. That's what we're talking about. The graph seems to shift. How? Well, I think in this case, it didn't go up and down. It actually went what? Left and right. Left and right. Placement of the number this time was inside the bar or inside the parentheses. And the number of units is exactly the same as the number or opposite the number. So let's take a look. When this one goes left 2, it looks like the number that we landed on is negative 2. But yet the number inside is positive 2. So it looks like we went opposite. Let's see if that holds true on the right. This one goes right 3. So if we landed, we would land at positive 3, which is opposite of what we see in parentheses. What we see in there is negative 3. So this is actually the relationship we're talking about. What I want to do is make sure that you understand that we can actually talk about numbers that are inside, and we can talk about numbers that are outside, okay? Inside and outside. Let's just say I had something like this, or I had this one. Okay, notice that this is a number on the inside. This is a number on the inside. This is what I call inside close to x, or inside the parentheses close to x. The numbers that are beyond the bar or past the parentheses, these are numbers that we're going to call outside. So these are considered outside. So when Miss Jessup is talking about numbers on the inside and the numbers on the outside, that's what I need you to think about. I need you to understand what I'm saying and why I'm saying it that way. So this is inside and outside. Okay, did you notice? Now what I did is I drew a dashed line representing the true. Remember how we're always comparing it back to the beginning? So the beginning equation would go up. My new one ended up coming on the bottom. So it looks like it flipped down. This one goes up. The blue dashed line goes up, but the red line comes down. How many graphs seem to flip down? The answer would be both did. So where is the negative sign located? The negative sign seems to be located in front. Notice that it's very beginning. It's right in front of the square root, and it's right in front of the x squared. So it's definitely in front. Number 7. Again, my dashed blue lines remind me where my original graph is. So if I put the negative inside with x on the square, my parabola is actually in the same exact place. But in number 8, if I draw it up and to the right, then this one actually looks like it flipped left. So I'm going to answer my questions. How many graphs seem to flip left? 1. And it says which one or ones would be number 8. Which one looked the same? Number 7 looked the same. And actually what it's actually saying is actually all the graphs, or both the graphs, were flipped left. But you just can't see the difference. So what that actually means is this side of the original graph got flipped over here. Okay? And then this side of the original graph got flipped over there. But in the end, the graph still looks like, in a black and white window in our calculator, it still looks the same. So technically, it did flip across the y-axis. This one you can easily see. So it's almost like we have the y-axis highlighted right through here, and what was over here gets flipped over there. It's the same thing right here. What was on one side gets flipped to the other side of the y-axis. So where is the negative sign located? This time we'd have to say it's inside close to x. Okay, so these graphs got flipped left. So it flipped the graph left. All right. All right, for this next part too, we're actually going to focus on x squared. And what I did is I made a table of values, and I'm going to use my equation. So the first thing I'm going to do is take negative 3, and I'm going to use it for x. So that's going to make it like negative 3 squared, which is negative 3 times negative 3 twice. So negative 3 is negative 3 squared is positive 9. Negative 2 times negative 2 twice would be positive 4. Negative 1 times negative 1 is positive 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. And 3 squared is 9. We now have specific points we can graph. I'm going to start right here in the center. We'll start at 0, 0. We kind of knew that was an important point on x squared. Now we're actually going to plot specific points instead of just graphing a quick shape. Okay, if I go to 1, 1, I'm going to come over 1 and up 1. If I go to negative 1, 1, I'm actually going to come backwards 1 and up 1. All right, and then I'm going to go right 2 from the center. I'm going to go right 2 and up. See, right 2 and up 1, 2, 3, 4. Then I'm going to go left 2, 1, 2, and up 1, 2, 3, 4. Then I'm going to do negative 3, 9, and positive 3, 9. From the center, I'm going to go 1, 2, 3, up 1, 2, 3, 4, 5, 6, 7, 8, 9. Going to go from the center, go back 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. If you see enough points, you should see a very symmetrical shape, and we can easily sketch in the shape, hopefully, of x squared. Again, it makes that nice U-shaped parabola. Maybe my drawing's not so perfect, but that's it. The one thing that I want to point out, I don't want you to overlook this, is it goes over 1, up 1 in the very first movement. Goes over 1 backwards and up 1 in the very first movement. So that 1 over 1 up 1 or back 1 and up 1, those are very key points because that's going to actually tell me whether I'm dealing with an A value in the front that's normal and regular or that it's a 1, or sometimes it can also tell me if it's different. So now let's take a look and see what happens if I change that number in front. Okay, and that's actually going to be ax squared. So we're actually talking about something that's going to be referred to as the A value. So this time I'm going to use my table of values, and I'm going to put -3. Now, order of operations tells me that if I use -3 for x, I need to actually square the -3 first. Then afterwards, then I'm going to double the answer. So you got to do the square before you multiply. So -3 times -3 is 9. 9 times 2, when I doubled it, becomes 18. -2 times -2 twice is +4. Doubled is 8. -1 times -1 is 1. Doubled is 2. And it's a typo. 0 times 0 is 0. And 0 times 2 is still 0. And then, did you notice that the left-hand side and the right-hand side of the graph is the same? So I'm going to bet this is 2, 8, and 18. All right, let's put these points on the graph. 0, 0. Seems like all of my graphs start in the very center at 0, 0. Then I'm going to come, this time, I'm going to, instead of going negative or +1 and up 1, 2. I'm going to go backwards 1 and up 1, 2. Okay. Then I'm going to come over 2 and go 1, 2 from the start. Over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. Going to come back to 1, 2, 3, 4, 5, 6, 7, 8. I don't think I have room for -318 or +318. So that's the points that I have to work with on my graph. Now what I'd like to do is I would like to actually compare the shape of that graph back to this graph. Again, that graph, the new one, to this one. Okay. Now notice on this one, what did we say happened at the very first movement? Well, from the center, from 0, 0, you go over 1, up 1, backwards 1, up 1. That is very important, okay? The very first movement from 0, 0 to get to the very first point, if you look at your x's and y's, from 0, 0 is over 1 and then up 1, okay? Over 1, up 1. Okay, now let's look what happens on this graph. If I look at the very start, I go over 1 and then I go up 2, okay? 1 and 2. I go back 1 and up 2. Okay, so it's always over 1, and then the next one is up 2. So it looks like I'm actually going up faster than normal. So I go over 1, up 2. That's key. Notice that the number was what? 2x squared. So what happens here is this one is what we call vertically stretched. Okay? We're not talking about the sideways directions, okay? We're talking about vertical. We're talking about the up and down direction. So it looks like we're stretching. It looks like we're reaching down and stretching it, pulling it up. So what happens is it's growing up at twice the rate, okay? It's growing up at twice the rate. Hence, that's where the number 2 comes from. Even on the second movement, okay? Remember, on the second movement, we go over 2 and up 4. Over 2 and up 4. And on this one, we're going over 2 and up what? 8. Over 2 and up 8. So not only did we double the first movement away from the center, we're doubling the second movement. So it's growing up at twice the rate. Now, something that we could observe is that it makes this one look kind of skinny. It looks like it hugs the y-axis, okay? So it's like it pulls it in. So that's what a graph looks like when you put a number bigger than 1 in the front, or what we call an A value bigger than 1. So right here's my A value, which is that number in front. Would it surprise you to learn that if you put a 3 in the front, if it was 3x squared from the center, we'd come over 1 and up 1, 2, 3. We would actually have a graph that would be 3x squared. We would actually have a parabola that was a little bit even more skinny. It's just an observation. We're going to talk about that in just a little bit. All right. Instead of doing timesing by 2, I'm going to actually do half. So I'm going to do 1/2. So now I'm going to let the a value, okay, the a value in front of x squared is now going to end up being 1/2. So this graph should only grow half as tall as the last one. Okay, I'm going to start in the center because I know that 0, 0. 0 squared is 0. 0 times anything like 1/2 is 0. Okay, let's put -1 up here. What's -1 times -1? +1. It's +1 times 1/2. Well, it's only half. What about -2? -2 times -2 twice is +4. Half of 4 turns out to be 2. -3. -3 times -3 is 9. Half of 9 is 4.5, or 4.5. How about -4? -4 squared, which is -4 times -4 is +16. Half of that would be 8. Okay? And if this is my top half, I'm going to bet my bottom half is symmetric to that, because so far there is a lot of symmetry to this graph. And I think we can put these points on here. But let's start with 0, 0. Okay, start with 0, 0. Then I'm going to come -1 and +1. So I'm going to come over 1. This time I only go up 1/2. Backwards 1 and only up 1/2. Then I'm going to come over 2. 1, 2, but I only go up 2. 1, 2. Okay, here, over 2, up 2. And then if I go again, I'm going to come over 3. 1, 2, 3, and up 1, 2, 3, 4.5. Come backwards, 1, 2, 3, backwards, up 1, 2, 3, 4.5. And then the last one is over 4 and up 1, 2, 3, 4, 5, 6, 7, 8. And backwards from the center, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8 up. This time the graph doesn't get skinnier. What happened to that one? Now I want to compare it not to the second one. I want to compare it to that one. Again, the first movement goes over 1 and up 1. Over 1 and up 1. That's really the only one you have to remember. This one goes what? Over 1. I'll just grab this one. It goes over 1, but it goes up what? It goes up half. It goes back 1, and it only goes up what? It only goes up half. And again, my a value turns out to be half. So what happens here is this one gets what we call vertically shrunk. It doesn't grow up nearly as fast as it should. So this one is what we call vertically shrunk. It only grows half as fast as the regular x squared. So remember, x squared is like your basic one you have to know. It's called the parent function. So x squared is a lot of times called the parent function. And the other ones that we do are kind of sort of sometimes called like, you know, like their daughter functions, or parts are related to the parent. So we're going to call it that. So that's the 1/2. So you kind of get the idea of what the a value does. So basically it's shrunk. It's almost like someone is sitting on this graph, pushing down on it, and it pops it out. That's what we think about with vertically shrunk. So it only goes, so this one looks wider. Okay, this one looks very wide. Again, my a value, okay, is less than 1. Okay, it's like 1/2, 0.5. Okay, so it could be like, for example, 0.5 x squared, which is the same thing as 1/2 x squared. All right, I could have 0.4 x squared, which would be the same thing as, I think, 2/5 x squared. So those graphs would look wider than normal. So we can have numbers that are smaller. Okay, just going to skip those for now. We want to go to this number 13, and we're just going to sketch. And again, I'm just trying to put together some of the ideas that we just talked about. So if I talk about this one first, I'm going to put this one in blue. It starts here. Over 1, up 1, left 1, up 1. Okay, and I'm going to sketch it. Okay, just kind of sketched it. What's going to happen when I put a half? We just did this one. So from the center, I'm going to come over 1 and only up 1 halfway. Over 1 and only up halfway. That one got a little off track. So here's my green one. Okay, that's my green one, so that would be like 1/2 x squared. What happens if we only have 1/4? Well, you come here and you only go up about 1/4 of the way, so that would be even what? That won't be even wider. What about 1/8 of the way? 1/8. So that would actually make it even wider. So everybody sees what's happening. Okay. When compared, it says, what does the effect does having a smaller and smaller a value have on the graph? It looks to me like it gets wider and wider. That's the observation that I hope you can see. All right? Okay. Now, this is just summarizing some of the things that we did just a second ago. So I'm going to start with x squared and put it in blue. Okay. X squared comes over 1 up 1. Remember that over 1 up 1, that is the basic parabola that we all need to know. Okay. The board's just a little bit off. What happens if you put a 2? Now, we did this one specifically. If you remember, go back a couple of slides. If you want to double check, pause the video, go back a couple of slides. From the center, it goes over 1, but it goes up twice as much. Remember, it climbs twice as fast. So I actually end up with a parabola that is skinnier than normal. What would happen if we put a 3 in the front? Well, from the center, it would come over 1 and up 1, 2, 3, over 1 up 1, 2, 3. So this parabola would be even skinnier than that one, and so forth. Okay, so what happens, what effect does having a larger and larger a value? The graph is vertically stretched up, and it looks skinny. Okay, that's a good way to talk about it. All right. Now, we're going to, it says clear the graphs in your calculator. You know, you put these in your calculator. I now want to do this shape. And this is your basic graph. Remember, this is square root of x. This is the one that starts at 0, 0. Okay. And then it's half of a sideways parabola. Okay. Now, I have my picture down here. I'm going to start with this. So I'm going to put my 0, 0 point. Now, here's a point that is in common. So if I was to have a table for this one, if this was x and this is square root of x, okay? What if I let x be 0? Well, what is the square root if you put 0 under there? Well, it turns out it's just 0. So 0, 0, which is the point I just put on the graph. What if x turns out to be 1? So in this column, it would be square root of 1. Well, the square root of 1, that's a perfect square. 1 times 1 is 1. That actually comes out to be 1. What that means is you now have a key point. It's going to come over 1 and up 1 in the very first movement, and that means that it kind of tells you where the shape of x, square root of x, my bad, square root of x comes from. Now what happens if I put a half in front? Half in front, okay? Let me go back and summarize one more time, okay? This one goes over 1 and what? Up 1, over 1, up 1. That's what those means. And that's in the very first movement, okay? That's the first point after 0, 0. And that's very much the same as how we did the x squared graph too. Now what happens here is you're going to come over 1, but you're only going to go up, guess what? 0.5. Or 0.5 is the same thing as what? 1/2. So I'm going to come over 1, but I'm only going to come up halfway. That is 0.5 square root of x. That graph got even smaller, didn't it? What happens if you put 0.25? That's actually the same thing as 1/4 square root of x. Well, I'm still going to go over 1. You always go over 1. But this time you're just going to go up what? We're just going to go up 1/4. So if I only go up 1/4, that's 1/4 the square root of x. So what effect does this have? All right, this one grows. Gropes. No, not gropes. This one grows up at 1/2 the rate. Okay, and it makes it look lots flatter than the regular square root of x graph. Okay, in other words, this one's actually shrunk also. This one will be called vertically shrunk. It looks like someone's sitting on it and pushing it down. It's like they're sitting on it, pushing it down. Okay, kind of trying to flatten it out. They're not going to flatten it out. There's always going to be a slight curve on that, but it does look flatter and flatter. All right, so that's what happens. It's really the same idea because you're still talking about vertically growing. Pretty much we're going to wrap this up. And so I guess I actually answered the observation question over here on this slide right here where we're talking. So I've actually already answered that question. So let's talk about the last one. I'm going to graph this one. Okay, square root of x. Remember that starts at 0, 0. And your very first movement is always going to be over 1 and up 1. So right there is square root of x. Now what happens if I put a 2 in the front? Okay, remember, it's going to grow up 2 times faster. All right, so this means it's going to go over 1 and up what? 2. So I'm going to go from the center, always start at 0, 0, come over 1 and up 1, 2. That is 2 square root of x. So you can see it almost looks like someone reaches down, grabs it, and pulls it up. Okay? All right, last one. What happens if we put a 3 in the front? It's going to grow up. It's going to grow up what? 3 times faster than square root of x. Okay? That's the one that you always compare to, square root of x. So this one's going to come over 1 and up 3. So start at the center, same plane. Over 1, up 1, 2, 3. That right there is 3 times the square root of x. So what does the value larger and larger have? Hey, remember, it's going to be vertically stretched up, okay, it looks taller. So we are actually looking at what value the A has. All right. I'm going to show you these. These are like, I gave the students sticky notes. I gave them a choice of whatever color they wanted, and they could either have 1 or they could have 2. And the idea is if you want to make a sticky note with the bullets of information on it, then you can keep it and you can use it on the quiz. So if you want to pause the video, you can write these in, okay, add it or subtract it at the end, outside. The graph shifts up or down, same as the number. The number on the inside with x, the graph shifts left and right opposite the number, and it talks about a negative in front and a negative inside. That's the summary of the very first, that's the summary of the points that we were trying to learn with numbers 1 through 8. Okay, so when we circled those questions, this is actually those bullet points. If you want a second sticky note, I'll get there. I guess that's another copy because I've done it a couple of times. If you want a second sticky note, hang on. Did I delete the thing? I may have deleted. Yep, no, that would be it. If you want a second sticky note, or even on the back, this is talking about the A value. Remember, the A value is the number in front. When it's less than 1, like for example, if it's a half, or 0.5, or if it's a fourth, or 0.25, you know, anything that's basically smaller than 1, your graph's going to get wider. Okay, it's going to vertically shrink. Okay, or it gets wider. If it's x squared, it's going to get flatter if it's square root of x. Remember how that graph kind of sort of gets really flat looking? And this one's going to get really wide looking because it looks like someone's sitting on them, and it just makes them kind of pop out or go down. When the number is bigger than 1, like 2 or 3 or 4, ... it's greater than 1. The graph gets skinny because it's vertically stretched, or it gets taller. Okay, remember the square root graph kind of starts to, it looks like it's reaching up farther, so it actually comes up. So it can be skinnier or taller. If you want to take a couple of sticky notes, summarize the information, again, you can pause the video, then you can write this information on a sticky note for yourself. Okay, and I think I've got it a couple of places. Here I have the notes, the same notes. Okay, they were just written a couple of different times. Again, pause, look at it, write your notes in. There's actually only two different pages. All right, as we wrap this up, The first night of homework, I ask you guys to graph these, and all you're going to do is you're going to do one problem at a time. So like if we were to do number 1, all I'd ask you to do is to write down the equation. So on your paper, you would say the g of x equation, or you can write y equals x squared minus 2. Well, the first thing I remember is x squared is that U-shaped graph that touches 0, 0. If it says minus 2, it's asking me to describe the changes. All I want is phrases. I think this right here makes it go down 2. And then the last thing, it says sketch on a coordinate graph. So if I just sketch a little x and y axis, if it goes down 2, boom, boom, there's my new point. So my U-shaped graph just goes down 2. I have completed number 1. You are welcome to use your calculators. If you need help to see what they look like, please do. They're going to progressively ask you to do more and more things. Number 8 is going to ask you to do 3 things. I believe the sign in front is going to make it flip down. I believe the +3 on the inside, remember inside is opposite and it goes left or right. So this is going to make it go left or possibly right. And it's also going to do that opposite the number. The inside always goes opposite. And this is not a fantastic way to remember that, but it is a way to remember it. If you are on the inside, think about a jail. You're inside the slammer. You're in the jail. And chances are you're in the jail because you did something opposite from what society said you should. And so inside is opposite. If you're on the outside of the jail, there's a good chance that you're walking around doing your normal life and you're living life the same as you should live it. Okay, so it's not a great way, but it is one way to remember it. So I'm going to go left and right opposite. Here, I'm going to go up or down, same as the number. Okay, so in this one, it does flip down, left and right opposite. So if I were thinking about that, see, it looks like it's +3. But opposite of that would actually flip it back to what? -3. So this actually makes it go left 3. Okay. Now, subtract 1, same as the number. So that would actually go down to -1. So that's actually going to go down 1. If I put all of those pieces together, all of those pieces, then I would simply draw a sketch. This is number 8 again. Okay. I know my graph's going to flip down. That'll be the last thing I do. I'm going to go left 3, 1, 2, 3, and then I'm going to go down 1. And I'm down 1, and then I'm going to put a mark, and it turns down. That is a quick sketch of number 8. Good luck, and come see me at Smart Breakfast if you need any help.